Hello kids, hopefully you have finished your AP problem, turned it in, and don't forget that our test is on Wednesday for the series test. We are almost done with it. Can you believe that? Your homework is about absolute and conditional convergence. It's like an add-on almost to the stuff that we've already learned. So here are your book problems. So in your notes, you want to talk about absolute convergence, right? Do not answer absolute convergence questions if you aren't asked. So if somebody just asks you about convergence, you answer like you have so far. When I say absolute, I want you to think absolute value. And what that means is if I say a series absolutely converges, regardless of whether the signs alternate or the signs don't alternate, I will get convergence. So for example, look at this series. Now this is just numeric, right? There are no x's in this. Come on, pen. Right? This is a numeric series. So, does this numeric series converge or not? Well, by the alternating series test it does, right? Because for the alternating series, as long as your terms go to 0, without the alternating series, without the the signs alternating, and it will converge. So by the alternating series test, yes. So I got converges by the alternating series test. Now, the question for absolute convergence is, does the fact that the signs alternated, which think about what that means. If the signs alternating, what you're adding is, right, you're adding smaller and smaller numbers, but you're adding a small positive number, then a small negative number, which means you're subtracting, right? Then adding a positive number that was smaller than before, but then the next term you're subtracting something even smaller, right? So kind of think about what that's doing. And I consider the absolute value of the series, does it converge anyway? So if I just look at no alternating signs, I get 1 over 2n plus 3 factorial. With factorials, I told you one of the hints to use to what test to run on that would be the ratio test. I'm not going to show the ratio test right now, but it will, if you run the ratio test on this numeric series, you will get a limit that is less than 1, and therefore this series converges. Now what that means is, since this series converged even without those alternating signs, which means even without subtracting all those every other term, right? Subtracting a value because of every other term, we can say this series converges absolutely. Now, conditional convergence means the series will only converge if the signs alternate. So look at this series. Again, this is numeric, right? This is numeric. There are no x's in here. So when I look at this, right, this is a p series with n to the right, n to the 1, but it's an alternating p series. So again, by the alternating series test, this series converges. But now I want to say, I wonder if it would converge even if the signs were all positive? Or does the convergence depend? That's the conditional, right, piece. Depend upon the fact that every other term is negative. So I took the absolute value of the series and I got 1 over n, which is the harmonic series, and that diverges because it is a p series with p equal to 1. Therefore, the original alternating series is not absolutely convergent. It's not absolutely convergent because in order to get convergence, you had to have every other term be negative, or in other words, an alternating series. This series converges conditionally. Now notice in both of these examples that were numeric, I said the overall series converged absolutely or converged conditionally. Now, how do I take that into power series? To find the interval of convergence. Okay, remember to find the interval of convergence. Oops, sorry. To find the interval of convergence, you have to consider endpoints. That's what we learned before, right? So the IOC means you have to test each endpoint. And remember, when you test an endpoint, you create a numeric series. So let's look at this series. This series does alternate. Can you see that it is a power series? So it is not just a numeric series, it's a power series. So I would run the ratio test on this to find the radius of convergence. So think about the radius of the ratio test. It has absolute value in it. So every x inside the interval creates an absolutely convergent series, right? You're doing the ratio test. The ratio test takes the negative, the alternating, pieces out of it. So for every x inside the radius of convergence, you have absolute convergence. So again, I'm not going to do the ratio test on this in this lesson. We've already practiced that. But the radius of convergence from the ratio test was 2. Sorry. Right? Radius of convergence was 2. My center is at 0. And that's how I got the open interval -2 to 2. For the interval of convergence, I need to test the endpoints. So do the endpoints create convergent or divergent series? So the first thing I did was replace the x with the left endpoint. That's what I did right there. So again, I did the algebra like we did from the interval of convergence lesson, and I did my algebra and I reduced stuff, simplified stuff, and I got a divergent series, numeric series. Then I did the right endpoint. And I got that the right endpoint creates a series that converges by the alternating series test. Therefore, the interval of convergence has an equality only at the right endpoint. So I say the series converges conditionally at x equals 2. Why conditionally? Because the only way I got the convergent series was because the signs alternated. If both endpoints are either excluded or included, there is no conditional convergence. Right? It doesn't make any sense to talk about whether I have conditional or absolute at -2. Right? So the only time you have to worry about whether a series converges conditionally is if you have one of the endpoints, right? One of the endpoints had equality, right? And when I put that right endpoint in, I did not have an alternating, I had the alternating series, right? So the only way to get convergence at 2 was if you had the signs bounce back and forth. Okay? So try your book homework with these problems. This is not heavily tested on AP, so don't stress too much about it. As a matter of fact, AP took it out of the curriculum for about 7 years and then plopped it back in just a couple of years ago. So don't stress too much about absolute and conditional convergence. For us, we are talking about just, dealing with the power series here and at the only worrying about the endpoints. Okay? Have a good one, and I will see you later.